It is not acceptable to install a standard SU cord under a raised floor in an information technology room, even if the equipment it connects to is listed. According to the National Electrical Code, specifically Section 645.55, cables installed under raised floors in such rooms must meet specific fire-resistant requirements. Listing of the overall equipment package does not automatically qualify the connecting cord for underfloor use. The cord needs to independently meet the standards for fire resistance. The NEC requires that cables in this environment be listed as Type DP cable, or possess adequate fire-resistant characteristics suitable for under-raised floors of an information technology room. The fact that the cord is labeled UL water-resistant SU, CSA negative 40 degrees Celsius, FT-2P-7K 123,033 MSHA 600 volts does not automatically qualify it as meeting the DP cable or equivalent fire resistance requirement. These markings indicate other characteristics such as water resistance, cold temperature rating, and voltage rating, but not necessarily fire resistance as required for underfloor installations. Power extension cords, in general, must also meet the requirements for DP labeling and fire-resistant characteristics if they are used under raised floors. The NEC requirement applies to all cables installed under the raised floor, irrespective of whether they are permanent wiring or temporary extension cords. The standard to reference for fire-resistant characteristics is ANSI/UL 1581.1991. This standard outlines the testing procedures and acceptance criteria for determining the fire-resistant properties of cables. Now let's delve deeper into the reasons and implications of these requirements. The primary concern is fire safety. Data centers and information technology rooms contain a high concentration of electrical equipment, which inherently poses a fire risk. The raised floor creates a concealed space where a fire can spread rapidly, potentially causing extensive damage and disrupting critical operations. Firstly, the NEC is a set of standards created to ensure the safe installation of electrical wiring and equipment. Secondly, Article 645 addresses the specific requirements for information technology equipment and rooms, recognizing the unique hazards associated with these environments. Thirdly, the raised floor introduces a hidden space where airflow is restricted and fire detection can be delayed. The materials used in this space, including the cables, must be chosen to minimize the risk of fire spread. Type DP cables are specifically designed and tested to resist the spread of fire. They are constructed with materials that are less likely to ignite and burn, and they may also incorporate features such as fire retardant coatings or barriers. This is why the NEC mandates their use in underfloor applications. The listing of equipment by an approved testing organization, as mentioned in the question, indicates that the equipment itself meets certain safety standards. However, this listing does not extend to the connecting cord unless the cord is specifically included as part of the listed assembly and meets the underfloor requirements. The equipment manufacturer's statement that the equipment is listed and meets the requirements for its intended usage is relevant to the equipment itself, but not necessarily to the cord's suitability for underfloor use. The local building inspector's advice to ensure that cords under the raised floor are properly rated underscores the importance of complying with the NEC requirements. Building inspectors are responsible for enforcing the code and ensuring that electrical installations are safe. The SU cord is a flexible power cord designed for general purpose use. The letters SU stand for Service Oil Resistant Outer Jacket, Oil Resistant Insulation, and Water Resistant. While it has some desirable properties, such as oil and water resistance, it is not specifically designed or tested for fire resistance in underfloor applications. Using a standard SU cord under a raised floor could violate the NEC requirements and pose a fire safety hazard. Regarding extension cords, it's a common misconception that they are exempt from the same requirements as permanent wiring. However, the NEC makes no such distinction. Any cable installed under a raised floor, regardless of whether it's a permanent cable or a temporary extension cord, must meet the DP cable or equivalent fire resistance requirement. This is because the fire hazard is the same regardless of the cable's intended duration of use. The ANSI/UL 1581 standard, mentioned in the answer, provides detailed specifications for testing the fire-resistant properties of cables. This standard includes tests such as the vertical tray flame test, which evaluates the cable's ability to resist flame propagation. Cables that pass this test are considered to have adequate fire-resistant characteristics for underfloor use. To ensure compliance, it's essential to carefully select cables that are specifically listed as Type DP or that have been tested and certified to meet the requirements of ANSI/UL 1581. Documentation from the cable manufacturer should be available to verify the cable's fire-resistant properties. In summary, installing a standard SU cord under a raised floor in an information technology room is not acceptable, even if the equipment is listed. Power extension cords must also meet the same fire-resistant requirements as permanent cables when used under raised floors. It is important to consult the NEC and relevant product standards such as ANSI/UL 1581 to ensure that all cables used in this environment meet the necessary safety requirements. Failure to comply with these requirements could result in code violations, increased fire risk, and potential damage to property and equipment. The requirements aim to mitigate the specific risks associated with underfloor installations in data centers and information technology rooms. Compliance with these standards is crucial for ensuring the safety and reliability of these critical facilities. The NEC is updated periodically to reflect the latest technological advancements and safety concerns. It is important to stay informed about the current edition of the code and any local amendments that may apply. Local building codes may have additional requirements or interpretations that are specific to the jurisdiction. Consulting with a qualified electrical engineer or inspector can help ensure that the electrical installation complies with all applicable codes and standards. Proper cable management practices can also contribute to fire safety. Cables should be neatly organized and supported to prevent them from becoming tangled or damaged. Overloading circuits should be avoided, as this can lead to overheating and increase the risk of fire. Regular inspections of the electrical installation can help identify potential hazards and ensure that the system is operating safely. Any damaged or worn cable should be replaced promptly. By following these guidelines and adhering to the NEC requirements, you can help minimize the risk of fire and ensure the safe operation of your information technology room. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified expert before making any decisions about electrical installations. Now to delve deeper into the specifics of DP cable and its fire-resistant properties. DP cable is specifically designed to limit the spread of fire in concealed spaces like under raised floors. It's constructed using materials that either don't readily ignite or have self-extinguishing properties. This characteristic is crucial in preventing a small electrical fire from escalating into a major incident. The NEC mandates DP cable not just for its flame retardancy, but also for its low smoke characteristics. In the event of a fire, DP cable produces less smoke than standard cables, improving visibility for emergency responders and facilitating safer evacuation. This is important in a data center environment where quick response is critical. When selecting DP cable, it's important to look for the appropriate listing and certification marks. These marks indicate that the cable has been tested by a recognized testing laboratory and meets the requirements of the relevant standards. The UL listing is a common and widely recognized mark for electrical products. The certification process involves rigorous testing to ensure that the cable meets the specified performance and safety standards. Manufacturers of DP cable can provide detailed specifications and test data to verify the cable's fire-resistant properties. This information should include the results of the vertical tray flame test and other relevant tests. If documentation is not readily available, it's best to choose a different cable from a reputable manufacturer. The fire-resistant properties of DP cable can degrade over time due to exposure to heat, moisture, or chemicals. Regular inspections can help identify any signs of degradation, such as cracking, discoloration, or brittleness. Damaged or degraded cable should be replaced immediately to maintain the integrity of the fire protection system. In addition to DP cable, other fire-resistant cabling options may be available. These cables may use different materials or construction techniques to achieve the required fire-resistant properties. The NEC allows the use of alternative cabling methods as long as they provide an equivalent level of fire protection. It is important to carefully evaluate any alternative cabling options and ensure that they meet all applicable code requirements. It's critical to remember that the DP designation is more than just a label. It signifies a comprehensive design and testing process focused on fire safety. The material science behind DP cables includes polymers that char when exposed to flame, forming a protective layer that insulates the underlying conductors. This charring effect slows down the burning process and reduces the spread of fire. The internal construction of DP cables often includes features that further enhance fire resistance. For example, some cables may incorporate a layer of fire retardant tape or a barrier that prevents flames from traveling along the cable length. These design features work in conjunction to provide a high level of fire protection. Extension cords introduce another layer of complexity. Their flexibility and portability make them convenient, but also increase the risk of damage or misuse. Extension cords used under raised floors are particularly vulnerable to being pinched, kinked, or otherwise damaged. Regular inspections of extension cords are essential to identify any signs of wear or tear. Damaged extension cords should be removed from service immediately and replaced with new cords that meet the DP cable requirements. It's also important to use extension cords of the appropriate gauge for the intended application. Using an undersized extension cord can cause overheating and increase the risk of fire. The current carrying capacity of an extension cord is determined by its gauge, with lower gauge numbers indicating thicker wires and higher current capacity. The NEC provides guidance on selecting the appropriate gauge for extension cords based on the amperage of the connected equipment. As a rule of thumb, it's always better to use an extension cord that is slightly oversized than one that is undersized. This provides a margin of safety and reduces the risk of overheating. When using extension cords, it's important to avoid overloading them. Overloading an extension cord can cause it to overheat and potentially start a fire. The maximum load that an extension cord can handle is typically indicated on the cord's label. It's important to never exceed this rating. One of the most common causes of extension cord fires is the use of multiple extension cords connected together. This is often referred to as daisy chaining. Daisy chaining extension cords can overload the circuit and increase the risk of fire. It's always better to use a single extension cord of the appropriate length than to connect multiple cords together. When not in use, extension cords should be properly stored to prevent damage. Extension cords should be coiled neatly and stored in a dry, well-ventilated area. Avoid storing extension cords in areas where they could be exposed to moisture, heat, or chemicals. Proper storage can help prolong the life of extension cords and reduce the risk of fire. The selection of appropriate cabling is a critical aspect of data center design and operations. Data centers house a vast amount of sensitive electronic equipment, and any disruption to their operation can have significant consequences. Fire protection is a key consideration in data center design. The use of DP cable and other fire-resistant materials helps to minimize the risk of fire and protect the valuable equipment housed within the data center. The NEC provides a comprehensive set of guidelines for electrical installations in data centers. Compliance with these guidelines is essential for ensuring the safety and reliability of the data center. Regular inspections and maintenance are also critical for maintaining the integrity of the electrical system. Data center operators should establish a proactive maintenance program that includes regular inspections of all electrical components, including cabling, connections, and power distribution equipment. In addition to the NEC, other standards and best practices may apply to data center electrical installations. For example, the Telecommunications Industry Association (TIA) has developed standards for cabling systems in data centers. These standards address issues such as cable management, grounding, and bonding. Following these standards can help ensure that the cabling system is properly installed and maintained. As technology continues to evolve, the electrical requirements of data centers are constantly changing. Data center operators need to stay informed about the latest technological advancements and code changes to ensure that their electrical systems are up to date and compliant with all applicable regulations. Ongoing training for data center personnel is also essential. Data center personnel should be trained on the proper procedures for operating and maintaining the electrical system, as well as emergency procedures in the event of a fire or other electrical incident. This training should be regularly updated to reflect the latest changes in technology and best practices. The investment in fire-resistant cabling and proper electrical installation practices is a worthwhile investment that can protect data centers from costly downtime and potential disasters. The NEC-specific requirements for cables and underfloor applications highlight the unique risks associated with these environments. The fire can spread rapidly, potentially causing extensive damage and disrupting critical operations. The Type DP cable offers enhanced protection compared to standard cables, and its use is essential for compliance with the NEC. Extension cords also fall under the same NEC requirements as permanent cabling when used in underfloor spaces, and their selection, use, and maintenance must be carefully managed to prevent fire hazards. By adhering to these regulations and best practices, data centers can ensure a safer and more reliable operating environment.